In this video, I will explain the concept of the current divider on three circuits which you can see on screen. The current divider is used to calculate the branch currents if you have a given input current. We will start with the basic principle, therefore we use the circuit of the two parallel resistors. As usual, we have to define our reference directions for voltage and current before calculating. We are looking for the currents I1 and I2. If we do not know the current divider rule, we could calculate them by applying Ohm's law in a parallel circuit. We should know that the voltage in a parallel circuit has to be equal. This results in V equals V1 equals V2. From here on we can apply Ohm's law for V1 and also for V2 and get 1 amp or 0.5 amp respectively. But what if we would not know that the input voltage V equals 10 volt? Instead we would know that the input current I is equal to 1.5 amp. Just to be clear, we could calculate the input current by applying Ohm's law to the input voltage and the total equivalent resistance. The total resistance in our case is R1 parallel to R2. Let's now move on with the assumption that we do not know V and we only know the input current I. The current divider rule in the special case of two resistors has two possible formulas. The first formula is the relationship of the branch currents. I1 over I2 is equal to R2 over R1. This form would be useful if we would already know one of the branch currents, which is unfortunately not the case. The second formula of the current divider rule is more useful to us. So the branch current I1 is equal to the input current times the resistance of the opposite branch over the sum of the two. Note that I have used RS for the sum instead of RT, because this is not the total resistance R1 parallel to R2. In our case, this equals I times R2 over R1 plus R2. Additionally, note the difference in indices because for the voltage divider we had the same indices in the numerator. For I2 we could do a similar calculation just with different indices. Let's apply the current divider to a more difficult circuit. We are looking for the current through resistor R3 and again we have to insert our reference directions. To make the contrast in calculation more clear, we start with an alternative calculation. If we would try to calculate the current with the voltage divider, we could say that V2 equals V3 and this equals input voltage V times R23 over total resistance. R23 is equal to R2 parallel to R3 and the total resistance is equal to R1 plus R23. Finally, we could apply Ohm's law and get I3. Again, this whole calculation is dependent on the input voltage. What if we would not have the input voltage? Instead, we would have the input current of 0.6 amp. Then we could immediately apply the current divider rule and say I3 equals input current times resistance of the opposite branch, that is R2, over the sum of both, and that is R2 plus R3. We would not even care about R1. So I3 equals 0.2 amp or 200 milliamp as in the simulation. Last but not least, I want to show how the current divider is applied if we are not in the special case of two resistors. Now we have 3 resistors, but this can be extended to more parallel resistors like 5, 6, 7 and so on. Again, we want to calculate the current I3, and for our reference directions we can be a bit lazy with our voltages, because they do not really matter if we are only interested in the currents. In the general case, the current divider has two versions of the same formula, and you can choose which you can remember easier. The first version is I3 equals input current times total resistance over R3. Be careful here, we have the total resistance and not just the sum. Additionally, we have in the denominator the same indices. The total resistance is given by R1 parallel to R2 parallel to R3. If we would have more than 3 resistors, we would just have a different total resistance. However, the same formula could be applied. In the second version, I3 equals input current times 1 over R3 divided by 1 over R1 plus 1 over R2 plus 1 over R3. Here we also have the same indices in the numerator. Two things are important on this formula. In the denominator, we do not have the total resistance because we are missing the 1 over part. And if we would have more than 3 resistors, we would just add it in the denominator like the others, with 1 over R4 plus 1 over R5 and so on. This brings me to the end of this video and the concept of the current divider. Thank you for watching.